Hello everyone, I'm Vandana, and in this video I'm going to talk about the types of chemical bonds, which are the ionic and the covalent bonds. So this is a part of class 10th curriculum. It comes under the chapter metals and nonmetals. Also, this video would be useful for anybody who wants to know about the types of chemical bonds, which are the ionic and the covalent bonds. So before I begin with the description about the ionic and the covalent bond, something that I want you guys to know about is that why are these bonds formed, and also about the noble gas configuration. So noble gases are basically, you can say I have a list here. So these are the various noble gases. So helium, neon, argon, krypton, xenon, radon. And I have listed the atomic number here and the electronic configuration. One thing that all the noble gases, are also known as the inert gases, have in common is that they would have their last shell completely filled. So basically we know that we write the electronic configurations. These are the various shells K, L, M, N, O, P that I've written over here. So you can see like helium, atomic number 2, and you can see K is its first and last shell here. So it has 2 electrons here, right? So this is the outermost shell, and the maximum capacity of K shell is also 2, so it is completely filled. For rest of the other gases, you can see that the last shell is completely filled, which means it has 8 electrons in the last shell. So basically all the noble gases would have 8 electrons in the last shell. Exception is helium in this case, because maximum capacity of the K shell is 2, and this is the last shell in this case. So the main thing is that all the noble gases, also known as the inert gases, are highly stable. So what does it mean, highly stable? It means that they're unreactive, do not react easily. So everybody wants to become more stable. Everything in the world wants to become more stable. So similarly, all the other elements wants to become more stable and achieve the noble gas configurations. That means that all the other elements want to have their last shell completely filled. This is the main key point here, that everybody wants the last shell to be completely filled, all the elements. And in order to get their last shell completely filled, they form bonds. So these bonds are formed so that they can completely fill the last shell and become stable, right? So I'll just share a list with you of some of the commonly elements we come across. So this is a very concise list basically. So these are the frequently used elements. There's an entire list that we need to cover, like at least elements till atomic number 20. But these are the ones which are frequently used, and I have collated the list here. So you can see this is hydrogen, atomic number 1. The electronic configuration is 1 in the first shell, which is the K shell. Similarly, you can see carbon, atomic number 6. So if you always fill the first shell first, so how are you going to divide these electrons among the shells? So first you always put 2 here, and then till up to 8 it comes here in the next shell. This is covered in class 9 syllabus. So basically it's like we all should know this, that the shells have to be filled in what order. Like the K shell has to be filled first, and it has the maximum capacity of 2, and like the next shell is the L shell, which would have the maximum capacity of 8, and the subsequent shells also. So you can see here, right, the various symbols, like Na is 11, atomic number is 11. This is something that we need to learn, the Na atomic number 11. So electronic configuration will be, you will fill, so you count this comes out to be 11, right? The first 2 here, then 8 here, then 1 here, which counts to 2 plus 8 plus 1 is 11. So you are distributing basically the electrons into various shells. So here one thing you'll observe is that these elements do not have their last shell completely filled. So here you can see it has 4, it has 5, but it's not 8, right? In the last shell, only the last shell we are considering. Even for, if you see for this H, so it would have like first shell and the last shell the same. So if it is 1, if it would have been 2, it would be really stable because the last shell would be filled. Similarly, if carbon would have last shell completely filled, it would be really stable, but it needs 4 more electrons to become stable. So basically what I want you to understand is that all the elements want to achieve the noble gas configuration. That means that they all want that the last shell would be completely filled. For most of the elements, that would be like having 8 electrons in the last shell, and for hydrogen and helium, helium is already stable though. Hydrogen, it would mean having 2 electrons in the K shell, right? So I'll just move on now. So just to summarize what I've done, what we have discussed so far, that the bonds are formed. Why are the bonds formed? Bonds are formed because all the elements wants to become really, really stable, just like noble gases are. They all want the last shell to be completely filled, So they all want the last shell completely filled. That's the reason that they all form bonds, right? Okay. So moving on, I'll just cover first the ionic bonds. So ionic bonds are basically formed by transfer of electrons. So this is something that we need to remember. Like ionic bonds are formed by transfer of electrons. Transfer means, somebody gives an electron to somebody else, right? So for example, Na, we just saw here in the list that Na atomic number is 11, right? If I distribute it in the shell, it comes up with 281, right? So somehow, if this Na is able to get rid of this one extra electron that it has, it would have 2,8 configuration, and it would be really, really stable. So this is basically I've written the configurations in the various shells here. So what it wants, somehow, if it can, I'm just writing the last shell electron here, which is shown by a dot. Somehow, if it is able to give minus electron, right, minus 1 electron, electron we denote by E minus sign, like this. So it is going to have 10 total electrons, which is going to be 2,8. Okay, and last shell is completely filled. So when it gives 1 electron, it gets a positive sign. Okay, to tell you why it gets a positive sign is basically, the number of electrons and protons are same in every element. So here it would have 11 electrons and 11 proton. When it gives or donates 1 electron, so these are, it's donating electron here. It is going to donate later, but I am just removing it here. So it's donating, or it gives an electron and becomes Na positive, right? So here positive denotes that the protons which carry positive charge are greater in number. Similarly, if you see Cl, so it has 287 configuration. 17 is the atomic number, right? So in the last shell there would be 7. 1, 2, 3, 4, 5, 6, 7 electrons. So this is 17. Atomic number is 17. So somehow, if it gets 1 more electron in the last shell, right? If I am somehow able to add 1 electron to it, it is going to have 2,8,8. The last shell would get 1 electron. This would be the new configuration. It is going to have, 8 electrons. And here, since it has taken 1 extra electron, it is shown by negative sign here. It means that it has excess of electrons. It has taken somebody else's electron, and so the number of electrons now are 18. and the protons are still 17, so it shows that excess of electrons are there. So this is one concept we need to understand before I move on to how the bonds are formed between these two. So basically ionic bonds are formed by transfer of electrons, right? So how is the transfer going to take place? So I had Na, which was carrying one extra electron. I had Cl, so let me denote the electrons like this with crosses here for Cl, so which had 7 electrons. So what Na is going to do is, Na is going to donate one of its electron to Cl. It says, okay, I have an extra electron here and you lack 1 electron. So if I just donate it to you, I'll have 2,8 and I'll become stable. And you will have 2,8 configuration and you'll also become stable because both of them have the last shell completely filled. So yeah, both are happy, both have their last shell completely filled. So so it will become, Na is going to be plus and Cl with 1 extra electron from Na is going to be minus, which is NaCl, right? So NaCl is an example of ionic bond. I hope it makes it a little clear. I'll just summarize what I've covered in this topic, ionic bonds. So basically we need to remember that ionic bonds are always formed by transfer of electrons. Somebody is transferring extra electron it has to somebody else. And one more thing I should cover is like ionic bonds would generally be formed between metals and non-metals. So between. So because metals generally are giving, they donate electrons or they want to give electrons, whereas non-metals wants to accept electrons. So you can say, for example, this is a metal. It wants to get rid of the extra electron. It wants to give or donate the electron, whereas Cl, it wants to accept an extra electron. So it's a non-metal. So ionic bonds are formed between metal and a non-metal. So you'll have a metal and a non-metal which will combine, right? And it's formed by transfer of electrons. So these are the 2 key points that we need to remember. Transfer of electrons, and it is between metal and a non-metal. So I'm coming to this equation. Na had 1 extra electron in the outermost shell and it lacked 1 electron in the outermost shell. So it gave its extra electron to Cl. It itself becomes a cation, which is positively charged ion, and this becomes an anion, Cl minus. So it forms NaCl, which is salt, right? There's one more example I want to take up, which is MgCl2, magnesium chloride. This was sodium chloride. So I'll just cover it over here. So Mg is 282 and Cl is, we just discussed, right, 287. So it has like Mg has 2 extra electrons in the last shell, right? Last shell has 2 electrons, whereas Cl we saw had 7 electrons. And I'll just take one more Cl. It also has 7 electrons. So what Mg is going to do is give 1 electron here, give 1 electron here, because earlier it had 287. So it had 2 extra electrons. It gave 1 to this Cl, 1 to this Cl. So this forms Mg. Now has gotten rid of these 2 electrons. So this becomes Mg2 plus, and Cl gets the extra electron from Mg. Each one gets 1. So I have 2 Cl minus. Like this. So this is actually MgCl2. This 2 gets here, which is magnesium chloride. I hope it makes some sense to you. Like again, the main thing is like transfer of electrons. Mg is transferring electrons to Cl here in this case. Okay, let's come to covalent bonds now. So basically covalent bonds are formed by sharing of electrons. So this is the main difference. So covalent bonds have sharing of electrons, whereas the ionic bond had transfer of electrons. And it is between two nonmetals. Covalent bonds can be like single bond, double or triple bond. So basically 3 types of covalent bond can be there. Let's take one example, like Cl. So you know Cl had, we just saw 7 electrons here, 7 electrons here, right? It needs 1 electron. This also needs 1 electron. So what it is going to do is, Cl says, okay, when I need an electron, I'll just borrow one from you or share one with you. So it has 8 now. It's sharing one of the electrons with the other Cl. Now similarly, it also takes 1 when it needs it. So basically they're sharing an electron, you know. So it's like Cl, and this, you know, these 2 electrons combine to form 1 bond, which is a single bond. It's like this. We generally denote like this. Sorry, let me take one more example. I'll just take CH4. So C is basically, we just did it, right? C is 6, so it has last shell, it would have 4 electrons. 1, 2, 3, 4. 6, when I say, it means it has atomic number of 6 in the table that we just saw. And so it's like configuration is 2, 4 in the K and L shell. So last shell has 4 electrons. So I'll just, I've just denoted these 4 electrons like this. Similarly, if you think of H is just atomic number is 1. So just the K shell which has 1 electron. So it is like this. Now what C is going to do is, C has 4 electrons. It wants to achieve the noble gas configuration, and it wants that its last shell should have 8 electrons. So what it will do is, it is going to form bond with 4 hydrogen atoms, and each hydrogen atom has its own, I'll just draw a note at the cross, has its own electron. So what it will do is, H needs 2 to become stable, 2 electrons in the shell, because K is the last shell in this case. So it becomes, shares it with carbon like this. And it needs, carbon needs 8 electrons to become stable. So 1, 2, 3, 4, 5, 6, 7, 8. Draw it like this. So again, 2 electrons combine to form a single bond, that I just told you, 2 electrons combine to form a single bond. So it will become like C, single bond, H, like this. This is actually joined like this. So now in this case, you can see that C also got 8 electrons and becomes stable. H gets 2, each H gets 2 electrons, and they also become stable. Let me take one more example of oxygen, which is O2. So oxygen has 6 electrons in last shell. This is basically 2, 6. So I'll take one more oxygen. So again 2, 6. What are they going to do is, let me just redraw these here, so that I'm able to show you the bond, how it is formed, and I'm just getting rid of these. So what it's going to do is, it is going to ask for 2 extra electrons from this oxygen. So 1, 2, 3, 4, 5, 6, 7, 8 completed here. And similarly, this oxygen is going to take it from the other oxygen, and 1, 2, 3, 4, 5, 6, 7, 8 here. These are going to form 2 bonds, which is like O double bond O, which is O2 basically. So this was Cl2, which was a single bond. This was CH4, which is methane actually, and this is O2. One more that I like to take up with you is a triple bond example, so which is N2. So N is basically atomic number 7, so it is like 2,5. So it has like 1, 2, 3, 4, 5 electrons in the last shell. So it needs 3 more. So it's going to share it with this nitrogen over here, 3, and again over here like this. This one is also, it's like this nitrogen is like 1, 2, 3, 4, 5, 6, 7, 8 completed the last shell. Similarly here 1, 2, 3, 4, 5, 6, 7, 8 completed the last shell. Denote it like 1 bond, 2 bond, 3 bond, because 1 bond is formed by 2 electrons. It's like triple bond N. So it's like this. Thank you. So basically this what I've covered today in this video is about ionic and covalent bonds. How are they formed and why are they formed? And we've covered something about the noble gas configurations, that all the elements want to become stable just like the noble gases. They all want to become highly stable and unreactive, and hence they form bond to completely fill the last shell. We covered ionic bonds. So ionic bonds are formed by transfer of electrons, and they are like between metals and non-metals. Also, one thing I would like to tell you is this, that since ionic bonds are made up of ions, one positive charge, one carrying negative charge, so they are very, very strong bonds. They would have really high melting and boiling point, because they have very strong force of attraction between them, these positive and the negative. You can see they are opposites attract, so they're like really strong bond between them. So very high amount of heat is required to break that bond. So high melting and boiling point, really strong force of attraction, and they would generally be solid, the compounds which are formed by ionic bonds. And coming to covalent bonds, so they are formed by sharing of electrons and would be between 2 non-metals. And so basically 3 types: single bond, double bond here, and triple bond. And they are like, because there are no ions involved, so they are like comparatively weaker force of attraction between these elements that you will see. And they have lower melting and boiling point, and also they would generally be like liquid or gases, and sometimes they'll be in solid state, the compounds which are formed by the covalent bond. So that's it for today. If you like the video, so please like the video and subscribe to the channel. I'll keep posting more videos. Thank you. Have a great day.